In this video, we're going to look at questions 15 to 20. Question 15. Ship K is 3,000 meters west of ship H. Ship K, ship H, 3,000 meters. So the minimum speed which H must travel to intercept, so needs to go in this direction. If this guy K is going 12i plus 6j, he's going in this direction. So the j velocity is much max. So he needs to travel at 6j meters per second in order to keep on the same j velocity as k. At some point they're going to come across each other, and that's going to be due north. Now we're told the speed is 10 of h, but we need to know we have ti plus 6j. Now that is going to be equal to 10. So we're going to have the square root of t squared plus 6 squared being equal to 10. You should see that t is 8 here. T squared plus 36 is equal to 100. So t squared is 64. So t, in fact, it could be plus or minus 8 in this case. So will both of these work? They don't always, but in this case I think they do. So we're going to have minus 8i plus 6j, or 8i plus 6j. So you can see he can go minus plus, is going to be in that direction. He'll intercept it going in that direction with an angle in here. And he could also go in this direction, and he will intercept it at some point as well. And the angle will be this angle in here. So we have an angle A and an angle B. So if we look at, this is my velocity of h, just put your t in. So if we look at angle A, well, they're both the same angle, they're just going in different directions. We have our I being 8 and our j being 6. So the tan of A is 6 over 8, which is 3 over 4 if you want to change it. So the inverse tan of 3 over 4, the inverse tan of 3 over 4 is going to give me 36.87 degrees. So what directions can he go in? This way or this way? We call this one A. So A is 36.87, and it's going to be north of east. No, sorry, north of west, not north of east, north of west. And B is going to be my 36.87, and that's going to be north of east. So they're the two directions, and I think we're asked time as well. Find the time of the interception in each case. So the time we need relative distance and relative speed. Okay, time equals relative distance. We've seen this already over relative speed. We have the relative distance, we have the 3,000 meters from the beginning, so the relative speed. So we've two velocities of h, so we want the velocity of k relative to h, which is equal to the velocity of k minus the velocity of h. And we have k, what was k traveling at? 12i plus 6j. So we're going to have 12i plus 6j minus, we do this one first, minus 8i plus 6j. That's going to give me 12i, and the j's are going to cancel, so we're just going to get 20i, and that will be meters per second. So this one here, for this one, 20 in, it's going to be 300 divided by 2, 150 seconds. And our next one is 12i plus 6j minus 8i plus 6j. And that's going to give me 12 minus 8, just 4i meters per second. So we're going to get 3,000 divided by 4, which is 750 seconds. Okay, let's look at 16. Ship X is 40 kilometers due west of ship Y, and ship Y is traveling north at 10 kilometers an hour, and ship X can travel at 20 kilometers an hour. The captain of ship X wishes to intercept ship Y. Show that the captain must steer the ship in a direction 30 degrees north of east, and after how long will X intercept Y? Okay, just a quick sketch to help us here. X is west of Y. This is 40 kilometers. Ship Y is traveling north at 10 kilometers an hour. So he's going in this direction. So the velocity of Y is 0I plus 10J. So X is going to be traveling in this direction to try and intercept them. And the velocity of X, he can travel at 20. Okay, well that will give us some information, but if we just call this Ti, the J velocities will have to match here. Obviously, we're going to say that T squared, the square root of T squared plus 10 squared is equal to 20. Travel at 20. So T squared plus 100 is equal to 20 squared, which is 400. So T squared is equal to 300. And that's going to be T is equal to square root 100 by square root 3, 10 root 3. And that's, I'll write that my vector first. Velocity of X is equal to 10 root 3 in the I direction plus 10 in the J direction. So now let's have a look at this direction here for X, this angle in here. So my angle A, my opposite is my J, so my 10 and my 10 root 3. The tan of A is equal to opposite over adjacent, which is equal to 1 over root 3. So the inverse tan of 1 over root 3, you all already know all this, is equal to 30 degrees. And that's what we were asked to show. So quadrat demonstrandum. And after how long will X intercept Y? So we just need the relative distance and speed. So the velocity of X relative to Y is the velocity of X minus the velocity of Y. What have we got here? We have Y, which is just 0Y plus 10J. So X was 10 root 3I in the I direction plus 10 in the J direction minus my 10 in the J direction, which is just going to leave me with 10 root 3I. And if I square that and get the square root of it, it's going to be the same number. So we can say that the relative speed, so my time being my relative distance over my relative speed, is going to be equal to, was it 30 kilometers? 40 kilometers. 40 kilometers over 10 root 3. And that, I don't think we're calculating, even 4 over root 3 is going to be a decimal, so that's equal to 2.31 hours. And if we convert that to hours and minutes, 2 hours and 19 minutes. Question 17, 10 hours or 1000 hours. Ship A is positioned 2I minus 3J kilometers relative to a fixed point O. So we just imagine this is the origin, traveling at 3I plus J kilometers an hour. At the same time, ship B has positioned 37I plus 25J kilometers relative to a fixed point O and is traveling at minus 2I minus 3J. So show if they continue at these velocities, they will collide, and find the time at which the collision will occur. Let's just do a sketch of these. So ship A is at a position 2I minus 3J. We'll just do a relative sketch, 2I minus 3J. So somewhere in here, this is ship A. And he is traveling at a speed of 3I plus J. So he's traveling in a positive direction. He's going in this direction here, with a wobbly line because he's on the sea. At the same time, ship B has positioned 37I plus 27J. So he's up here somewhere, ship B. And he's traveling in a minus direction. So he's going down Now he'd be much more over in this direction, so you can see I'll put him over here actually just to do a proper sketch. B is going in this direction here, and he's going at a speed, yeah, minus what we said, minus direction. So something like this for the sketch. So show if they continue at these velocities, they will collide. Okay, we start this by the displacement of them. We're given the positions, so displacement of B relative to A, displacement of B minus displacement of A, and my B position is 37I plus 25J. And my A position is 2I minus 3J. So that's going to be equal to 37 minus 2, 35I, and 25 plus 3 plus 28J. Now if we look at the velocity of B relative to A, the velocity of B relative to A, we know this has to be a constant times the other one. So the velocity of B minus the velocity of A is going to give me, velocity of B is minus 2I minus 3J. And then it's going to be minus, and A was moving at 3I plus J, which is going to give me minus 2I minus 3J minus 5I, which is a seventh of 35, so we should get 4 here, minus 3J minus J minus 4J. So you can see here that the displacement of B relative to A is equal to 7 times minus 7 times the velocity of B relative to A. So therefore, on collision course. So we ask the time here, the time to the collision time. It's going to be my relative distance based on their positions. So we have this here, so it's going to be the square root of 35 squared plus 28 squared over the relative speed, which is the square root of 5 squared plus 4 squared. Does this work out evenly for me? Actually, they're a factor of each other, so they will. 7 root 41 is the top, and root 41 is the bottom. So it's going to be 7 hours, the time of collision, after the time at which they start, which was this 10 o'clock in the morning. So 10 o'clock, 2 hours to 12, another 5 left. So that's 1700 hours for them to collide. Now on to the last two. 1 o'clock in the morning, 0100 hours, ship X has position 10I minus 4J relative to a fixed point and is traveling at the speed 3I plus J. At the same time, ship Y has position 37I plus KJ relative to a fixed point and is traveling at 1 kilometer an hour due south. Given that they're on a collision course, find the value of K. Okay, so we follow the same procedure again. The displacement of X, 10I minus 4J. And the relative position of is Y. Y is equal to position speed. So my position for Y is 37I plus KJ. So we get the relative position of X with respect to Y, or Y with respect to X, it doesn't really matter, is going to be like 37I plus KJ. Just trying to make them positive here, minus 10, rather than having 10 minus 37 minus 4J. So that's going to be 27I plus, we're going to have KJ plus 4J, so plus K plus 4 times J. So if we get the relative velocities, velocity of X is 3I plus J, And the velocity of y, 1 kilometer due south, so minus j, 0I minus j. The velocity of y relative to x, that's what we did before, isn't it? Yeah. So that's equal to 0I minus j minus 3I plus j, which is going to give me 0 minus 3 minus 3I minus j minus 2j. Now, given that they're on a collision course, find the value of k. If we just check back on the previous one just to show you something. What's the relationship between 35 and 5 here? 35 divided by 5 is 7, and 28 divided by 4 is 7. So we can say that as a fraction, the i's over each other have to be equal to the j's over each other. So the i's over each other will be 27 over minus 3 is equal to the j's over each other, k plus 4 over minus 2. So this should work out just minus 54 is equal to minus 3k minus 12. 3k is equal to 42. 54 minus 12, 42. K is equal to 14. So we ask the time. Okay, so we just need the relative positions, which was, the relative position was this one here. So the relative distance is equal to the square root of 27 squared plus, what do we have, 14 and 4, 18 squared over the relative speed, which my velocity have here, 3 squared plus 2 squared, and that's going to give me 9 root 13 on top and root 13 on the bottom. That is a 3, so that's 9 hours, and I think it was 0100 add on 9, we're going to get 10 o'clock in the morning here, 10 a.m. for collision. And lastly, number 20, at midday, a ship P has position minus 11I plus j relative to a lighthouse O. At the same time, the position of a boat Q is 4I minus 13j relative to O. The velocities of P and Q are 3I kilometers an hour and xj kilometers an hour. If they're on a collision course, find x, and again, when will they collide? Okay, let's look at the positions here and the velocities. P is minus 11I plus j, and Q 4I minus 13j. Going backwards will give me the positive value, so I'll do that. Relative position of Q relative to P, displacement of Q relative to P is 4I minus 13j minus 11I plus j. So that's going to give me 4 plus 11, it's going to give me 15I, and minus 13 minus 1 is minus 14j. The velocity of P is just 3I plus 0j, 3I plus 0j. Just put in the zeros to make sure you match the i's off and j's off just in case. And here we have 0I plus xj. So we did Q relative to P. It's going to be equal to 0I plus xj minus 3I plus 0j. So that's going to give me 0 minus 3 minus 3I and just xj plus xj. And similar to the last one, this is the ratio of the i's so and j's, so 15 over minus 3 has to equal minus 14 over x. So 15x is equal to 42. x is equal to 42, oh, not 45, 42 over 15. What does that work out to be? Just 14 over 5, 14 over 5, 14 over 5. You could write that as 2.8 if you want. So the time is going to be the relative distance over the relative speed. So you have my 15 and my 14. Over my 3 and my x. So that's going to give me my time, and that works out to be, exactly 5. T is equal to 5 hours. And the time of collision, I think it was midday, so 5 o'clock in the afternoon, another crash, 1700 hours. 1700 hours for collision.